Now we said that massive objects curve space, but really massive objects like black holes curve space so severely that space is warped and twisted completely around it. Okay? Black holes are formed when massive stars die. Those stars are many times the mass of our sun. They explode in a supernova, and the remaining mass collapses down to an area only a few miles across, about the size of a city. Let's imagine we could have an Earth mass black hole. We can't, but we're imagining. Let's say that all the mass of Earth, okay, where's Earth?
Right here.
Right here, we're standing on it, right? We're going to take all the mass of Earth and squeeze it inside of this marble. All right?
Is that possible?
Is that possible? No. But this would represent the dimensions of a black hole that had the mass of Earth. Space is curved completely around black holes, warping, twisting space around it. Remember that how much space is curved around an object depends on two things: the mass of the object and the distance from its center. All right? Now we're standing here on the surface of the real Earth. Right? Which direction is the center of Earth?
Down.
Right down.
Right, straight down, right. Now, Earth is about 8,000 miles across. So how far away is the center of the Earth?
4,000.
There you go. Okay. That's where Earth's center of mass is. Now, where's the center of mass of this black hole here?
Right in the center.
Yeah, just in the center. It's a couple inches away, right? Let's use this to represent the black hole with the mass of Earth.
Okay.
Now, let's take this Earth mass black hole far out in space.
Right.
Okay, we're way, way out in space now. And we're floating in space. Now, we'll use this, okay? See, can you feel the black hole in there?
Okay, so that represents this.
That represents this,
Gotcha.
exactly, right. Now, we're going to go out in space, take this way out in space. We're floating out in space near this black hole. Okay, floating? You feel yourself floating?
Absolutely.
Okay, cool. Now, how far away are you from the center of mass of this black hole?
2 feet.
Yeah, a couple feet, right. Now, if we moved ourselves 4,000 miles away from this black hole,
Right.
we would feel the same gravitational pull that we do standing here on the surface of Earth. Because, why?
Because it's 4,000 miles away from it.
From the center of mass, in both cases. Exactly, right. But here we are, far out in space, just a few feet from this Earth mass black hole. Would space be curved a lot
Yes.
where we are? And would we be pulled more strongly toward the black hole? Yeah, absolutely. Than we are
Right.
back
yes.
there on Earth. But what would we have to do to stay out of the black hole?
We would need our own propulsion to
Orbit it,
keep
I
away
guess.
from it.
Yes, we would have to go, yeah, we would have to orbit it, absolutely. And how fast would we be having to orbit it?
Very
Pretty fast.
Very, very fast, yes. Almost the speed of light is how fast we would have to be orbiting it. Now, these marbles represent tiny satellites orbiting the black hole. Can you put one into orbit? All right. Wow, very nice. You notice that the orbit degrades, right? Now, why do you suppose the orbit is degrading here?
Because there's actually substance here, it's not just space.
Yeah. If there wasn't any fabric here and this really was a black hole, it would just keep orbiting. And it would be going a lot faster than that. Now, if we were to stop orbiting and fall in, passing through this boundary of space into the region of the black hole, we would be trapped inside. Gravity would be so strong, we would be crushed to an unimaginable density, becoming part of the black hole.
Scary.
Now, no one has actually ever visited a black hole. The nearest black hole is many light years away, many trillions of miles. NASA continues to search for black holes in our galaxy and other galaxies to learn more about what actually happens very, very near black holes.